ancient Greek philosophers, such as Aristotle here, thought that the universe was infinitely old and thus had no beginning. During late antiquity and the medieval period, many theistic thinkers broke with that intellectual tradition on both theological and philosophical grounds. For example, the famous 12th century medieval Muslim philosopher Al-Ghazi argued that the very idea, the very concept of actual infinities entailed various absurdities, such that the concept didn't make sense, and that therefore the past must actually be finite rather than actually infinite, which means that the universe must therefore have had a beginning. Al-Ghazi made the finitude of the past a premise and an argument for the existence of God, which is known today as the Kalam cosmological argument. Kalam is an Islamic word that meant speech. It was kind of the term for the tradition of natural theology in Islam. So this quote here from Al-Ghazi, who argued that every being which begins has a cause for its beginning. Now, the world is a being which begins, on the basis of his argument that the very idea of an actually infinite past makes no sense. So the past must be finite, so the universe had a beginning, from which he then draws the conclusion that therefore the world, the universe, it possesses a cause for its beginning. So there's a cause for the beginning of the universe, and thus a cause outside of the universe. And you can see that that starts to sound at least a little bit like what theists mean by saying God. Belief in a universe with no beginning became fashionable again in the 18th century, due in part, at least, to the influence of the German philosopher Immanuel Kant. As philosopher of science Stephen Mayo observes, few physicists or astronomers at the beginning of the 20th century doubted the infinite age of the universe. In 1927, the Belgian cosmologist and Catholic priest Georges Lemaitre combined Einstein's theory of gravity with the observation of a Doppler shift in the light from progressively distant galaxies to formulate what would come to be known as the Big Bang theory. Big Bang was actually a disparaging label given to it by people who didn't like the theory, but it kind of stuck as a label. The Big Bang theory of the origins of the universe. Now, Big Bang cosmology has developed over the years since the 1920s, but the basic picture of a universe with a beginning a finite time ago has been the scientific consensus since particularly the 1965 discovery of the cosmic background radiation left over from the Big Bang, when the universe was a lot smaller, it was much hotter, and you can detect that today in the microwave wavelength of energy. And that was something predicted by the Big Bang model and then confirmed experimentally in 65, and mapped with progressive detail by a series of satellites from Kobe through to Planck in the 2013's Planck satellite. So to quote from New Scientist magazine, this is from a 2012 article, the Big Bang is now part of the furniture of modern cosmology. It now seems certain that the universe did have a beginning. Without an escape clause, physicists and philosophers must finally answer a problem that has been nagging at them for the best part of 50 years. How do you get a universe complete with the laws of physics out of nothing? Now, it's important to note that Big Bang cosmology describes the evolution of the universe, that is the change over time of the universe, from a very hot, very dense state a finite time ago to a much bigger, less hot, less dense state today. So it describes that evolution. But Big Bang cosmology does not say anything about what brought the universe into existence, as it were. It's a quote from Marcus Chown. That is, Big Bang cosmology offers a description of the cosmic past as being finite in extent. It doesn't offer an explanation of that finite cosmic past. And I often used to meet 16, 17-year-old students in schools when I used to go into schools doing school conferences on this kind of material, and meet students who would say things like, "Oh, you can't believe in God these days, you know, science has explained everything, we know why the universe is here because of Big Bang." As if the Big Bang was somehow a sort of alternative to believing in a creator. Because they have this idea that the Big Bang theory is an explanation for the existence of the universe. But it's not. It's just a description of the past of the universe. A description that I think very poignantly raises the question of how do you explain the universe, as that previous quote from New Scientist made clear. The atheist philosopher of science Bradley Monton, we quoted him yesterday, he says, if the universe had a beginning, then that lends support to the Kalam cosmological argument, kind of revives that argument. And it was particularly the American Christian philosopher William Lane Craig, who in the late 70s did his first PhD. There's not too many people you can say that phrase of. His first PhD in philosophy on this issue of the Kalam cosmological argument and marrying that with modern cosmological data. So he looked at both the kind of philosophical arguments against an infinite past that Al-Ghazi would have used, but then married it with looking at contemporary Big Bang cosmology as empirical scientific support for that first premise of the Kalam cosmological argument. Here's a quote from atheist Nobel laureate in physics Steven Weinberg. He says, "The Big Bang theory is as certain as anything in science. I suppose nothing in science is ever mathematically certain, like 2 + 2 = 4, but it's the kind of certainty that simply makes it not worthwhile considering alternatives." And the atheist cosmologist Alexander Vilenkin said, the answer to the question, did the universe have a beginning, is, it probably did. We have no viable models of an eternal universe. So, we can build that scientific theory into a Kalam argument for God. And let me share with you the way in which I would put such an argument. Premise 1, truth claim number 1. There was probably a first physical event. If you think of the history of the universe as a series of physical events, however you want to kind of divide it up, there being a beginning, there being a finite history, means that there would be a first such physical event. Second premise, second truth claim. Every physical event has at least one cause, at least in a very general sense, outside of itself. Now, if both of those truth claims, both of those premises are true, it follows deductively that something else must be true. You might be ahead of me here. But I just want to note, you can give a subsidiary argument for this second premise. You might think, why believe that every physical event has at least one cause outside of itself? So here's an argument for that. And then we'll see whether you were right about what you would deduce from those two premises. So think of this. Anything that's contingent or dependent for its existence on something else has at least one cause outside of itself. Premise 2, physical events are contingent or dependent realities. It seems like there could not be any physical things at all. That seems a possibility. The fact that there are seems to be contingent. Now, if those are both true, then it would follow that every physical event has at least one cause outside of itself, which was our second premise, from which it would follow that, therefore, there was probably, note that probably has been carried forward from the first premise, there was probably a first physical event with at least one cause, in a very general sense, outside of itself. But remember, we're talking about the first physical event of the universe, whether you want to say that's the existence of physical things happening over the period of a second, in the number of seconds in the universe, or Planck times in the history of the universe, or however you want to divide it up. Now, as atheist Raymond Tallis, and again we quoted him a couple of times yesterday, says, recent attempts to explain how the universe came out of nothing, that there not being a cause of the universe. Attempts which rely on questionable notions such as spontaneous fluctuations in a quantum vacuum, which is not nothing. It's a quantum vacuum you can describe it, and it's not nothing, right? The notion of gravity as negative energy and the inexplicable free gift of the laws of nature kind of waiting in the wings for the moment of creation reveal conceptual confusion beneath mathematical sophistication. So here's a kind of second stage continuing on this argument. We've got to that conclusion that there was probably a first physical event. Every physical event has at least one cause outside of itself. Therefore, there was probably a first physical event with at least one cause outside of itself. Now we add in a new bit of information. Premise 4. Any first physical event must have a non-physical cause. You can't say, what was the cause of the first physical event? Oh, it was the previous physical cause. So that statement doesn't make any sense, does it? If there is a cause, by definition, it has to be a non-physical cause. Conclusion. Therefore, there was probably a first physical event with a non-physical cause. If that argument is a good one, if it's sound, that is, if all the premises are jointly more likely true than not, and all of the kind of conclusions, the bits where we draw a conclusion from those premises are kind of validly drawn, this, at the very least, shows that naturalism and materialism as a worldview is wrong. And it also starts to sound suspiciously like some kind of theism, right? Some kind of non-physical cause that brought the whole universe into existence. Who's always believed in something like that, you know? Let me put it this way with a lovely illustration that I often use that comes from the Catholic philosopher Richard Purtill. I like these kind of concrete illustrations to get your mind around these ideas. Suppose I ask you to loan me a book, like my most recent book, A Universe from Someone, a collection of papers on arguments for the existence of God. I ask you to loan me a book, but you say, oh, I don't have a copy right now, but I'll ask my friend to lend me his copy, and then I'll lend it to you. Okay? But suppose your friend says exactly the same thing to you, and so on ad infinitum, to infinity, as the Latin phrase goes. Surely two things should be clear. First, if the process of asking to borrow the book goes on ad infinitum, then I'll never get the book from that process. Secondly, therefore, if I do get the book from the process that led to me getting it can't have been one that went on ad infinitum. That is, somewhere down the line of requests to borrow the book, someone had the book without having to borrow it from someone. Okay? Now, in this illustration, receiving the book is receiving existence being caused. Okay? So this is like somewhere down the line of receiving existence, something had to have existence without having to get it from somewhere else, right? Because that process of causation can't have gone on ad infinitum. It must be finite. See the application. Likewise, argues Richard Purtill, consider any contingent or dependent reality, such as any physical event, I would say, including, of course, the first physical event. He says the same two principles apply. If the process of everything getting its existence from something went on to infinity, then the thing in question would never have existence. And if the thing has existence, then the process hasn't gone on to infinity. There was something that had existence without having to receive it from something else. And it kind of seems to make sense that if there is something that's the kind of thing that just has existence without needing to receive it, without being dependent, without being contingent, then it must be the kind of thing that is independent in its existence, that is non-contingent, or philosophers would say necessary in its existence, such that if it did exist, not only can we say there was such a thing, there is such a thing. And that would also answer questions not only about, why did the universe come into existence, but why do we continue to exist moment by moment? You can kind of run the same kind of argument from, I think it's raised in a very interesting way by saying, there's a first physical event, looking backwards in time. But you can also say, well, why does anything here and now exist if physical things don't have to exist? Why do they continue in existence? So as American philosopher Dallas Willard would argue, the dependent character of all physical states, together with the completeness, the finiteness, the non-infinite, actual infiniteness, the completeness of the series of dependencies, A depends on B, depends on C, and so on, underlying the existence of any given physical state, logically implies at least one self-existent and therefore non-physical, because no physical thing is self-existent, state of being. Now that is, philosophically, I think, a very interesting part of the puzzle of existence. To be able to say a self-existent, i.e. independent in its ability to exist, a self-existent and therefore non-physical state of being that caused the existence of the physical universe, is a good slice of what theists mean by God. Shall we move on to a second aspect of Big Bang cosmology, which describes not only a finite changing past of the cosmos, but has in recent decades revealed that that cosmos has a special structure to it when you're looking at the initial conditions and the kind of laws that describe the universe and its change over time. A matter that's come to be colloquially known as the fine-tuning of the cosmos. Beginning with atheist astrophysicist Fred Hoyle's 1953 prediction of a finely tuned resonance state in the carbon-12 atomic nucleus, something that was later verified and is now known as the Hoyle state. Scientists have come to recognize that the existence of, well, not life, but not only life, kind of basically anything very interesting at all, but especially what philosopher Robin Collins calls embodied conscious agents, ECAs, embodied conscious agents, like ourselves, that is, observers able to significantly interact with each other, to develop science and scientific technology, and to discover the universe. These are all sort of different aspects of this fine-tuning. That all of this depends upon a staggering degree of cosmic and often more local and planetary even fine-tuning as well. So here's what Fred Hoyle kind of complained as an atheist. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics. Well, British Christian philosopher Richard Swinburne lays out one version of what he calls the principle of credulity, or principle of when to trust the way reality appears to you, when to trust the apparent evidence. And he argues that it's a basic principle of knowledge, which he calls the principle of credulity, that we ought to believe that things are as they seem to be until we have evidence that we're mistaken. And of course, trusting that evidence to show us that we were mistaken in one instance means trusting the evidence that shows we're mistaken. If we didn't trust any evidence until we had evidence that it was trustworthy, then you couldn't trust the evidence unless you had evidence that it was trust, and so on and so on and so on, and you end up in this regress and you can't believe anything. So basically, the rational thing to do, you have to start out trusting something, and that doesn't mean you're not open to being shown wrong. Indeed, you can't be open to being shown wrong unless you're willing to trust the way things appear to be. So we have a kind of, on the face of it, a prima facie argument for design which uses this principle, and we can apply that to the fine-tuning of the universe, because we say, one, we should take things to be the way they seem to be until given sufficient reason for doubt, and two, the fine-tuning of the cosmos seems to be the product of design, like Fred Hoyle was complaining, then of course the conclusion follows that we should take the fine-tuning of the universe to be the product of design until and unless we're given sufficient reason to doubt that. Is William Lane Craig describing the cosmic fine-tuning in a little bit more detail for us. The scientists have discovered that the existence of intelligent life, and indeed kind of complex chemistry, and indeed chemistry, and so on, depends upon a complex and delicate balance of initial conditions given in the Big Bang itself. In addition to the laws of physics themselves, this fine-tuning is of two sorts. First, when the laws of nature are expressed as mathematical equations, you find appearing in them certain so-called constants, like the constant that represents the force of gravity. The laws of nature are consistent with a wide range of values for these constants. There's no apparent physical reason why gravity has to be that strong and not a bit stronger or a bit weaker or a lot stronger or a lot weaker, and so on. Could have been all sorts of values. Second, there are initial conditions on which the laws of nature operate. For example, the amount of entropy, or the balance between matter and antimatter in the universe. That's just kind of an initial given that then changes over time in ways described by laws of physics with certain constants in. But you have to have the initial conditions as well. So those are two kind of separate things. These constants and quantities fall into an extraordinarily narrow range of life-permitting values. For example, a change in the strength of the atomic weak force by only 1 part in 10 to the power of 100, it's a very small number, very small change, because that's a very big number, 10 to the 100, would have prevented a life-permitting universe. The cosmological constant that drives the inflation of the universe is fine-tuned to around 1 part in 10 to the power of 120. The odds of the Big Bang's low entropy condition existing just by chance are on the order of 1 out of 10 to the power of 10 to the power of 123. For those not used to scientific mathematical notation, like me, concrete examples really help. It's generally estimated that there are something like 10 to the power of 80 atoms, I think it is, in the observable universe. So these numbers are much, much bigger. So Craig observes that for us to detect design rationally, in addition to high improbability, there also needs to be conformity to an independently given pattern. He's saying it's not sufficient for us to observe something and say that thing is very, very unlikely. Therefore, it must have been designed. That won't work. Roll a dice a lot of times in a row. You will get a very, very, very unlikely result. That is not enough to show that the result was designed. So he says, we also need conformity to an independently given pattern, not one that we've just read off the dice rolls, but an independently given one. He says, when these two elements are present, we have what's called specified complexity, which is the tip-off to intelligent design. And he gives this lovely example. He says, thus, in a poker game, any particular deal of cards is equally and highly improbable. Right? It's one hand of cards out of all the possible hands of cards that you can make out of the deck. Right? And everybody who's dealt around the table gets a hand of cards. All of those hands are equally improbable, and they're all very unlikely. But of course, that's not enough to prove that your hand of cards was the result of design rather than chance. Yeah? But, says Craig, if you find that every time a certain player deals, he ends up getting all 4 aces, you can bet this is not the result of chance, but of design. And that dealer who keeps getting all 4 aces couldn't allay our suspicions by saying, "What are you complaining about, suggesting that I'm cheating? After all, every hand of cards is equally unlikely." Or someone enters a sequence of numbers into a cash machine and it gives them money. Were they A, lucky, or B, did they get the money by design? Now, of course, you might say, well, it's possible that they were lucky. Maybe they were lucky. But which is the more probable explanation? Which is the best explanation? That they were lucky or that they got the money by design? When a complex, that is synonymous with unlikely, you can use those terms interchangeably here, complex and unlikely event matches an independently given, particularly useful here would be a functionally specified pattern. That's the only PIN number that will access money from the account attached to this card. It's a functionally specified pattern that has to be hit. We tend to infer design, and quite rationally so. So here's Stephen Hawking and Leonard Mlodinow from their book, The Grand Design. They note that the initial state of the universe had to be set up in a very special and highly improbable way. In effect, they're saying the initial state of the universe exhibits specified complexity. How improbable? Norwegian philosopher Espen Løkhammer quotes cosmologist Luke Barnes, pictured here, who has calculated using conservative numbers the combined odds that a life-permitting universe should exist on the assumption that naturalism is true, so that these values all have to be hit kind of without design. What are the chances? It says it's less than 1 part out of 10 to the power of 136. It is difficult to exaggerate how unlikely this is. These numbers are literally beyond astronomically big, right? Or physicist Lee Smolin has calculated that the odds of life-compatible numbers coming up by chance is around 1 in 10 to the power of 229. Well, here's probably the most famous atheist in the world still, a fellow Brit, Richard Dawkins, author of books like The God Delusion, from which I'm quoting here, who says, "The laws and constants of physics are fine-tuned in such a way as to set up the conditions under which humans and their brains will come into existence." Well, we'll come into the second part of that later on today. But note, he's talking about fine-tuned in such a way as to. That is complexity and specification. Cropping up again. Really, we have this argument. 1, the fine-tuning of the universe exhibits specified complexity. 2, things exhibiting specified complexity are probably designed. Conclusion, therefore, the fine-tuning of the universe was probably designed. Right? So how would someone like Dawkins respond to that argument? Well, the most famous objection here would be the so-called multiverse objection. It's basically the idea of giving ourselves more rolls of more dice in order to make it more likely that our numbers will come up. The many universes objection actually denies premise 1 of that argument by hypothesizing the existence of an infinite, or at least a very large, multiverse of differently tuned universes. It's like walking into a clothes shop and they've got all sorts of different sizes of clothing. So it's not at all surprising that you find one that you can inhabit, that you can put on and wear. So Dawkins suggests there are billions of universes having different laws and constants. We could only find ourselves in one of the minority of universes whose laws and constants happen to be propitious to our evolution. So nothing to see here, folks. It looks designed, but actually, no, that's just misleading because there are billions of universes with different laws and constants. Problem solved, right? Well, I'd suggest there are at least 8 problems with the multiverse hypothesis, which I've arranged here roughly in ascending order of seriousness. Now, most of these objections, note, apply in spades, as it were, apply all the more to an actually infinite multiverse hypothesis. And there are, of course, additional objections to an actually infinite multiverse, particularly if you connect back to, say, Algahar's arguments against the concept of actual infinity making sense. There can be some application there. But anyway, the multiverse hypothesis is speculative. Astrophysicist Rodney Holder points out that the physics associated with multiverse models is speculative, to say the least, especially when it comes to string theory models. The theory is, of course, complex. Richard Swinburne says, to postulate a trillion other universes rather than one God in order to explain the orderliness of our universe, the only universe we observe, seems the height of irrationality. You'd need lots of differently tuned universes to improve the odds of having a single life-permitting universe. And why are they differently tuned to each other, and so on? Any scientific multiverse hypothesis has to posit some sort of universe-generating mechanism. And perhaps it's this universe-generating mechanism, rather than its results, that should be compared with the God hypothesis here. Well, Stephen C. Mayer says multiverse advocates must not only postulate many universes, but 2 distinct types of universe-generating mechanisms in order to explain 2 distinct types of fine-tuning: initial conditions fine-tuning and fine-tuning of laws and constants of physics. Yet, each of these universe-generating mechanisms themselves presuppose multiple hypothetical entities or processes. So it's a complex hypothesis. Now, philosopher Logan Paul Gage cautions that simplicity in explanation is a secondary virtue. It's not an automatic trump card. More complex theories should not automatically be discounted. Okay, fair warning. However, even if there is something of a discount on new tokens of old kinds, okay, we already know that a universe can exist, so perhaps it's less of a stretch to say maybe there could be lots of other differently tuned universes, rather than to say, maybe there's a non-physical intelligent creator, right? We sort of compare these hypotheses. But he says even if there's something of a discount on new tokens of old kinds, it isn't a blank check. One new kind of thing in our explanation would be more than offset by infinitely many new tokens of old kinds. So we have to think kind of carefully about this comparison here. And Gage argues that theism is simpler than naturalism in terms of the number of fundamental entities postulated. So theism postulates one creator God as the fundamental reality. Remember, back to Mayer's quote, he says the multiverse generating ideas within cosmology have to posit 2 different fundamental kinds of realities, as well as lots of different universes. And so that comparison is a complex matter, but maybe one could argue that the God hypothesis is simpler, right? 3 and 4, that the multiverse idea is empirically unverified stroke unverifiable, and it's ad hoc. So, here's a slide from The Simpsons. Okay, if X number of monkeys existed, then let's grant that they could type the plays of Henrik Ibsen, to choose a Norwegian writer, by chance. Just typing away randomly on their little monkey typewriters. If you've got enough of them, maybe they could do that. But anyone faced with the many monkeys hypothesis as an explanation for the works of Henrik Ibsen will ask, surely, if there's any independent reason to believe that there were X number of monkeys typing away at a lot of typewriters for long enough. Okay? If not, they will rationally reject the many monkeys hypothesis as an ad hoc hypothesis, one adopted purely for the purpose of saving a theory from difficulty or refutation, but without any independent rationale. That's what it means to be an ad hoc explanation. And they will favour the single author hypothesis. Surely the same thing goes for the many universes and one author of the universe hypotheses. Dawkins is really making this argument. He's saying, premise 1, if there were enough different universes, then the specified structure of our universe wouldn't be complex or unlikely enough to justify a design inference. So he needs this premise, premise 2. There are enough different universes in order to reach the conclusion that therefore the fine-tuning of the universe does not justify a design inference. Premise 2 is key here. This is why I have it flashing away. Warning, warning. Danger, Will Robinson. Yeah. There are enough different universes, but as astrophysicist Adam Frank says, there is no empirically grounded scientific reason to believe there is such a thing as a multiverse of parallel realities. There's just no evidence for that theory. Cosmologist George Ellis says that the existence of multiverses is neither established nor scientifically establishable, he says. 5, multiverse would be insufficient to explain away the data, perhaps. Even if a multiverse did exist, what guarantees that it would be big enough and varied enough to explain away the very high degree of fine-tuning that we see in our universe? Philosopher of science Bruce Gordon says there are many independent constants and factors that are fine-tuned to a high degree of precision. The cumulative effect of all of these fine-tunings significantly erodes the probabilistic resources of, say, the string landscape models. Graham Swinard helpfully points out that even an infinite number of universes may not give the attribute that is required, that is, a cosmos fit for life, even if there's an infinite multiverse. He says, as John Polkinghorne commented, the infinite sequence of even numbers is distinctly short of oddness. So just because there's an infinite number of things doesn't mean you're going to get the type of thing that we're trying to explain. You'd have to have some sort of explanation of why that infinity includes that type of thing, which goes back to the complexity and ad hoc kind of issues with the thesis. 6, multiverse is question-begging, as the agnostic cosmologist Paul Davies, author of books like The Goldilocks Enigma, why is the universe just right for life? He says multiverse theories merely shift the problem up a level from universe to multiverse. To appreciate this, one only has to list the many assumptions that underpin the multiverse theory. First, there has to be a universe-generating mechanism. In the case of eternal inflation, a a quantum nucleation of pocket universes, to be precise. But that raises the obvious question of the source of the quantum laws, not to mention the laws of gravitation, including the causal structure of space-time on which those laws depend, that permit inflation. Furthermore, if we accept that the multiverse is predicted by string or M theory, a version of string theory, then that theory, with its specific mathematical form, also has to be accepted as given. So Davies concludes that the multiverse theory cannot provide a complete and final explanation of why the universe is fit for life. It just points you to a whole bunch of other things that themselves need explaining. As Mayer says, not only does the universe-generating mechanism in inflationary cosmology require prior, unexplained fine-tuning, he says it actually requires more fine-tuning than what it was proposed to explain. He actually argues that it makes the problem worse when you try and push it back. When you try and push the ruckle in the carpet under the sofa, the ruckle actually gets bigger when you're trying to offload it in this way. You don't get rid of fine-tuning. Indeed, he argues you get more fine-tuning that needs explaining. That's from his book, Return of the God Hypothesis, which I highly recommend. Seventh, the multiverse idea arguably undermines the practice of science. Physicist Brian Greene says the danger here is that if the multiverse idea takes root, researchers may too quickly give up the search for underlying explanations. When faced with seemingly inexplicable observations, researchers may invoke the framework of the multiverse prematurely, proclaiming some phenomenon or other to merely reflect the conditions in our own bubble universe, and thereby fail to discover the deeper understanding that awaits us. So you observe something unlikely that seems to require explanation, and you say, oh yeah, but we live in a multiverse where all sorts of weird things happen, because unlikely stuff happens because of the multiverse. Nothing to see here, move on. That kind of undermines the rationale of doing science. Eighth, the hypothesis of a multiverse is actually disconfirmed. Rodney Holder again says, our universe is far more special than we would expect it to be, even if it were merely a random member or of the subset of universes that are compatible with our existence. So if you take the small subset of universes compatible with our existence, most of them are less ordered, less special than the universe we actually observe. Our universe is too fine-tuned to be explained away as just we happen to live in a random member of that subset. As atheist Roger Penrose writes in his book, Fashion, Faith and Fantasy in the New Physics of the Universe, consider how ridiculously cheaper, in the sense of improbabilities, it would be to simply produce, by the mere random collision of particles, the entire solar system with all its life ready-made, compared to the fine-tuning of the universe. So he says the problem is, why did we not come about this way, just random, get this patch, this island of stability, life-permitting stability? Why did we not come about this way, rather than from an absurdly less probable 1.4 times 10 to the 10 tedious years of evolution? Seems to me that this conundrum simply points to the incorrectness of the bubble universe idea, the multi-universe idea. Now, the danger that the multiverse hypothesis undermines science might, I'm told, be mitigated by the assumption that we are generic members of the multiverse, but that is an assumption that underwrites the problem of observational disconfirmation. So the undermined science and the observational disconfirmation problems actually form horns of a dilemma for the multiverse hypothesis. You have to face at least one of them. So in light of the cumulative case against it, I think the many universes objection does not constitute a sound defeater to premise one of the cosmic fine-tuning argument. Moreover, even if we were prepared to grant a multiverse, here's philosopher Michael Rota arguing that our evidence supports a designer whether or not we're in a multiverse. Because a theistic multiverse, maybe God made lots of universes, a theistic multiverse is a possibility, and a theistic multiverse would likely contain a higher proportion of life-permitting universes than would an atheistic multiverse, just kind of a priori. Thus, our relevant evidence is more to be expected on a theistic multiverse hypothesis than on an atheistic multiverse hypothesis. Maybe it wouldn't be as strong an argument, but even granting a multiverse, it still seems to be an argument for design. So Dawkins really retreats in his work to philosophical attempts to rebut these kind of design inferences from fine-tuning, for example. He says, the designer himself. This is very similar to the, but who made God question that you raised earlier. The designer himself, in order to be capable of designing, would have to be another, note this word, complex entity of the kind that in his turn needs the same kind of explanation. Oh dear. It says, if you're trying to explain something improbable, it can never suffice to invoke an entity that is itself at least as improbable. So he sets this as a principle of good and bad explanation. Question, do we make an explanatory advance if we explain this complex self-portrait in terms of the existence of the yet more complex Edvard Munch? I think the question kind of answers itself. Of course we make an explanatory advance in explaining that painting in terms of Munch, even though Munch is more complex than his self-portrait. Dawkins' principle of explanation is just obviously wrong. Indeed, Dawkins thinks he's arguing that we should reject explanations that are more complex than the data they explain. But Dawkins is more complex than his argument. So by his own rule of explanation, he shouldn't believe he is arguing for his rule of explanation. That is, this objection is self-contradictory. And again, it doesn't get worse for you in philosophy than that. So here's a second attempt from Dawkins, the design rebuttal take 2. He says, critics of my book tried to deny that a God capable of designing something complex must himself be complex. But he says, God has to be clever enough to calculate the exact values of the physical constants that would fine-tune the universe. Call that simple? God has to have enough bandwidth to listen to all the prayers and praises of billions of people simultaneously. The one thing he can't be is simple. Well, in a debate that was chaired by the agnostic philosopher Sir Anthony Kenny, Kenny actually had a bit of an interaction with Dawkins on this matter. And Kenny distinguished between complexity of structure and complexity of function. And he used the illustration of an electric shaver, electric razor, and a cutthroat razor. And he said, the electric razor can only be used to cut a beard. But the cutthroat razor might also be used to cut a throat. Right? So he's pointing out that although the cutthroat razor is much more complex in its structure than the cutthroat razor. The cutthroat razor has what you might call a bigger complexity of function, things you can actually do with it. You can use it as a letter opener. You could chop your carrots with it. All sorts of things. The shaver is basically good for shaving beards, maybe as a paperweight or something, but fewer things, even though it's got more complexity of structure. In other words, demonstrating that something has complexity of function doesn't demonstrate that it has complexity of structure, because they're different things. Demonstrating complexity of function doesn't demonstrate complexity of structure. Back to Dawkins' quote, God has to be clever enough to calculate. He has to listen. Now, all the things that Dawkins raises are things that God has to do. They are functions. So Dawkins is trying to prove that God would have complexity of structure, needing explanation, like the fine-tuning of the universe, by arguing that God has complexity of function. Dawkins' response to Kenny was to say, I really don't see what you're saying, but I hope you do. He's saying that God can't be complex in the sense of being an unlikely contingent arrangement of parts, if, for example, God were to be a necessary being. So Dawkins is here begging the question against God being a necessary being, as is traditionally believed in theology. He's thinking of God like these OMG design your own deity fridge magnet sets that you can buy online, where you can mix and match your pictures of deities and come up with your own deity on your fridge. Because God is a complex arrangement of contingently linked parts. Well, no, that if some gods may be like that, but you can't just beg the question against God being a necessary being. So as the atheist Thomas Nagel responds to this kind of objection, he says, God, if there is one, is not a complex physical inhabitant of the natural world that needs explaining in the way that specified complex physical objects like the universe do. None of Dawkins' observations is an argument showing that God must be complex and not simple in the relevant sense. Dawkins equivocates over the terms complex and simple in order to beg the question against God being a simple stroke necessary being rather than a complex contingent being. As John Lennox wittily pointed out, a book called The Created God Delusion probably wouldn't have sold quite so many copies.